Hi, this is Jim from AWS. The topic of this session is migration design principles. In the previous video session, we highlighted key migration design areas. We learned there are many design topics. Instead of getting into those topics for detailed design, it is more important for us to consider fundamental design principles and use the principles to guide our design work. So let's look at some of the key design principles in this video session. Our starting point is the AWS well-architected framework, which we went through in the previous video session. Here, we describe the design principles for each of the 5 framework pillars: security, reliability, performance efficiency, cost optimization, and operational excellence. First, security. We surely need to be aware of and exercise security design principles because security is often customers' #1 consideration in their cloud journey. The first principle is the separation of security responsibilities between AWS and AWS customers. It is called AWS Shared Responsibility Model. Under this model, AWS is responsible for security of the cloud, including AWS infrastructure, hardware resources, and the cloud services. On the other hand, customer is responsible for security within the cloud, including customers' data, applications, and operating systems the application runs on. Second, apply security at all layers. Rather than just running security appliances at the edge of your infrastructure, use firewalls and other security controls on all of your resources, such as virtual server, load balancer, and the network subnet. Enable traceability is another design principle. It means logging and auditing all actions and changes to your environments. Use AWS CloudTrail, other API and service logging, and the CloudWatch log service. Implement least privilege. This principle ensures that authorization is appropriate for each interaction with your AWS resources, and implement strong logical access control directly on resources. Use AWS IAM. There are other security design principles. The audience is encouraged to read the AWS Security Best Practices document online. Reliability is one of the key migration considerations. Reliability is characterized by 2 metrics: availability and durability. Availability is determined primarily by failure rate, repair time, and fault coverage. Our goal for high availability is to prevent failure, minimize repair time, and increase coverage. Durability refers to the ability to perform required function over a lengthy period of time in present of failure conditions. Here are a few design considerations for achieving high reliability. First, scale horizontally to increase aggregated system availability. Consider decoupling one large resource with multiple small resources to reduce the impact of a single failure on the overall system. Use AWS Elastic Load Balancer to distribute requests across multiple smaller resources to ensure that they don't share a single point of failure. Second, employ replication to increase durability. We shall leverage replication capabilities by such AWS services as RDB, DynamoDB, and S3. The third consideration is testing recovery procedure to increase coverage. In the cloud, you can test how your system fails, and you can validate your recovery procedures. You can use automation to simulate different failures or to recreate scenarios that led to earlier failures. This exposes failure pathways that you can test and rectify before a real failure scenario, reducing the risk of components failing that have not been tested before. Last but not the least is about managing changes, which may have significant impact on reliability. Changes to your infrastructure should be made using automation. This way, the changes are consistently applied across environments and the potential operation errors can be minimized. Performance efficiency is reflected by two goals. One is to achieve high and sustained performance over time, and the other is to optimize performance of resources such as compute, network, storage, and the database. The migration design shall ensure the performance efficiency will be achieved above what the customer's data center can deliver today. We should consider data-driven approach, which means conducting load testing and benchmarking to determine performance against requirements, accordingly design or enhance architecture. Democratizing advanced technologies refers to leveraging cloud-native services that enable you to achieve higher performance with agility. For example, scaling up through EC2 sizing and scaling out using RDB replicas. Another design consideration is making proper trade-offs to improve performance. For example, higher performance can be achieved by relaxing constraints on consistency or durability obeyed by application requirements. Monitoring is a critical part of the design for performance efficiency. With monitoring information, you can remediate performance issues and fine-tune design and implementation for performance improvement. Cost optimization is a key motivation factor in the mind of many customers to migrate their applications from on-premises to the AWS cloud. Cost optimization needs to be carefully examined prior to migration and revisited post-migration. For cost optimization, we shall consider a consumption model that is pay as you go. With the consumption model in mind, your design shall use cost-effective resources to the maximum extent, which means, for example, right-sizing resources, selecting proper geographic service locations, and leveraging purchasing options, such as on-demand instances, spot instances, and reservations. To match supply and demand, consider demand-based approach, such as auto-scaling, buffer-based approach, such as SQS, and a time-based approach using job scheduling with spot instances. Finally, we need to track spending and accordingly optimize the cost over time. The design shall include resource usage measurement and monitoring as part of the cost optimization process. Operational excellence is an integral part of the migration process. It is particularly critical to reliability. One of the design principles is automation. The automation enforces consistency and prevents human errors in deployment and upgrade operations. Another principle is about change management. To minimize risks of production interruption from changes, we shall make regular, small, and incremental changes. We shall also keep operation procedures current to avoid errors or failures due to incorrect or mismatched procedures. Last but not least, test for responses to unexpected events. As described earlier, test helps increase coverage of faults and recovery operations. Test routinely and test as thoroughly as possible to be ahead of the game. Let's summarize what we just went through. For the migration design, we shall use the AWS well-architected framework, which specifies 5 architectural pillars or areas for design. To guide the design work, we shall consider and exercise design principles for each of the design areas. For further details, the audience can read AWS well-architected framework documentation online. Thank you for watching.